Hello students, welcome back to this channel. Please, if you are new here, consider subscribing. All right, and you're welcome to this last part of algebraic expression of complex number. We're going to be looking at division of complex number. So now, of course, this is the same example we are still looking at, but now we're going to be seeing how these two complex numbers, Z1 and Z2, can be divided. So we are asked to solve the following problems. So given that Z1 is this and Z2 is this, we are asked to find Z1 over Z2, again Z2 over Z1, again 2Z1 over Z2. All right, so in the case of Z1 over Z2, it means this divide by this. So we are asked to solve all of these things. And of course, in solving things like this, we are going to keep the final answer in the form of A plus BI. All right. Okay, so let's start with the very first one without wasting time. So the first one says Z1 over Z2, which is equal to. Now, in the numerator, we are going to put Z1, and in the denominator, we are going to put Z2. So our Z1 is 3 minus 3i. So we have 3 minus 3i all over. In the denominator, we are going to put our Z2, which is 4 plus 3i. 4 plus 3i. Now, there is something very important we need to know as far as division of complex number is concerned. All right, so in division of a complex number, the main aim is to get rid of I in the denominator. So by getting rid of I, we will multiply the numerator and the denominator with the conjugate of the denominator. And now, what do I mean by conjugate of a denominator? Or what do I mean by conjugate? So now, listen, conjugate of a complex number of, like I said in my first video, is nothing but a complex number obtained by changing the sign of the imaginary part. So when we say multiplying the numerator and the denominator by the conjugate of this denominator, it means that we are going to take the conjugate of this denominator and use it to multiply numerator and as well as denominator. Now, how do we get conjugate? Like I said, if you just change the sign of this imaginary part, whatever thing you have becomes the conjugate of this denominator. So, and now the conjugate of this denominator will be nothing but 4 minus 3i, because it was 4 plus 3i. So the conjugate will be 4 minus 3i. All right, don't forget, conjugate is only obtained by changing the sign of the imaginary part, not the sign of the real part. So it means that if the imaginary part is bearing a positive sign, change it from positive to negative. That which you have will be the conjugate. So here it is positive. So I'm going to change it from positive to negative. So by doing that, it will aid me to remove I from the denominator. So this is going to be times 4 minus 3i all over 4 minus 3i. And of course, mathematically, I've not really made any change to the initial question that was given to me, because this 4 minus 3i all over 4 minus 3i mathematically can still cancel out to give you 1. And if it gives you 1, if you use it and multiply the whole of this, it is still the whole of this. So what I'm actually doing mathematically is to create something that will help me to remove I in the denominator. Now watch carefully. According to multiplication of fractions, this is more like a fraction now. So how I'm going to do it is to take the numerator and multiply the numerator. Again, take the denominator and multiply the denominator. And there is something very important. Watch the denominators. This is 4 plus 3i. This is 4 minus 3i. Whenever a complex number is multiplied by its conjugate, it will give you a real number. So let me say it again. Whenever a complex number multiplies its conjugate, it gives you a real number. So multiplication of a complex number by its conjugate gives rid of I. So since our whole aim is to give rid of I by multiplying up and down by the conjugate of the denominator, we've succeeded in solving. So the same way we tackled the problem in multiplication of complex number, that is the same way we are going to tackle this one now. So we are going to say that the whole of this numerator are going to multiply themselves. So we can arrange it in this format that 3 into 4 minus 3i close, again minus 3i into 4 minus 3i all over 4 into 4 minus 3i close plus 3i into 4 minus 3i close. So we've arranged it. So we can now advance further by saying that z1 over z2 is equal to, now this 3 will open out this bracket, This minus 3i will open out this bracket, this 4 will open out this bracket, and this plus 3i will open out this bracket. So starting with this one, we now have that over here we have 12 minus 9i. Over here we have minus 12i plus 9i squared. All over. Over here we have 4 times 4, 16. We have 16 minus 12i. Over here we have plus 12i minus 9i squared. And if you focus your attention on the denominator here, you will notice that this and this are the same, so they can cancel out. So they are the same in signs, in magnitude, but opposite in sign, so they can cancel out. So, and again, I've also told you that this minus 1 is equal to I squared. This is very important key you understand. So in the course of evaluating this thing, wherever you see I squared, it is nothing but minus 1. So in this case now, in the case of plus 9i squared and in the case of minus 9i squared here, this I squared attached to these two things means minus 1. So I'm going to remove this I squared and replace it with minus 1. And of course here now, plus 9i squared is same thing as minus 9, because this I squared means minus 1, and that minus 1 will come out and multiply this plus 9 to turn it to minus 9. Again, this minus 9i squared, this I squared attached to it is same thing as minus 1, and this minus 1 will come out to multiply this minus 9 to give me plus 9. Therefore, I'm going to have that this is equal to 12 minus 9i minus 12i minus 9 all over. Here I have 16 plus 9. Very, very important. Okay, let me clean up and finish up here. Therefore, this minus 9, this is actually 12. Okay, so over here now, collecting like terms, both numerator and denominator, I will have that 12 minus 9 minus 9i minus 12i all over 16 plus 9. Now notice at the inception I told people that the aim of division of complex number is to get rid of I from the denominator, and if you watch carefully in the denominator there is no longer I. This is 16 plus 9 and it does not contain I again. So we can evaluate this finally to mean that 12 minus 9 gives us 3. We have 3 minus, and we have minus 9 minus 12, we have minus 21, minus 21 rather. 3 minus 21i all over. We have 16 plus 9, we have 25. Have 25. So which we can now break down as 3 over 25 minus 21 over 25. Over 25, then we attach this I. So this is the final answer in the form of A plus BI. So this is 3 over 25 minus 21 over 25, then you attach this I in the form of A plus BI. So please very quickly go through it and take your notes. So let us solve the second one that says Z2 over Z1. The same step anyway. The same step. So in the case of Z2 now over Z1, Z2 over Z1 is going to be, Z2 is this, and this is Z1. So we have 4 plus 3i all over 3 minus 3i. Now, like I said before, we are going to multiply numerator and denominator by the conjugate of the denominator. And I've said that a conjugate of a complex number is gotten by changing the sign of the imaginary part. So I'm going to have 3 plus 3i all over 3 plus 3i. So now, next step will be to arrange it in a way we can multiply it out. So we have 4 into 3 plus 3i. Next, plus 3i into 3 plus 3i all over 3 into 3 plus 3i. Next, minus 3i into 3 plus 3i. Okay, so next thing to be done is multiplying out now. So we use this 4 to open out this bracket, use this plus 3i to open out this bracket, use this 3 to open out this bracket, and use this minus 3i to open out this bracket. Doing that, we are going to have that this is 12, that is for this now, this is 12 plus 12i. Next, we have plus 9i plus 9i squared. That is 3 times 3. That is 3i times 3 is 9i. 3i times 3i is 9i squared. All over 3 times 3 is 9. 3 times 3i is plus 9i. Next, minus 3i times 3, we have minus 9i. Finally, minus 3i times 3i is what? Minus 9i squared. Don't forget that minus 1 is equal to I squared. Very important thing you understand. So evaluating further, we are going to have that this is equal to 12 minus 9 plus 12i plus 9i all over 9 plus 9 plus 9i minus 9i. All right, so this can cancel out. So in the denominator, I'll be left with 9 plus 9. Okay, let me clean part of here so that we can finish up the calculation. So 6. So this is the answer in the form of a plus bi. So 2z1 over z2. So in this case, it's going to be 2 into the z1 is actually 3 minus 3i all over z2, which is 4 plus 3i. Now multiplying up and down, or I can now decide to evaluate this further by saying that this is equal to 6 minus 6i all over 4 plus 3i times. Now at this point, I will now have to multiply up and down by the conjugate of the denominator, which will give me 4 minus 3i all over 4 minus 3i. Now expressing this further, I'm going to have that 4 into, that is, I'm focusing my attention on the numerator now. I will have not only 4, I'll have 6 into 4 minus 3i, then minus 6i into 4 minus 3i, close, all over 4 into 4 minus 3i, then plus 3i into 4 minus 3i. Okay, I hope you understand this part now, because what actually happened here is that this 6 multiplies this numerator on this part now, and this minus 6i multiplies this again, which is this. This 4 multiplies this, which is this, and this plus 3i multiplies this, which is this. So what I'm going to do next is simply to open out. But let me clean a part of up so that, or let me clean this part rather, and finish off on this part, since this is the last problem. Okay, next thing now, we're going to do 6 times 4, we have 24. We have 24. Then 6 times 3, we have 18. 6 times 4, 24. Then write it down here. 6 times 3, rather 6 times minus 3i, we have minus 18i. Next is minus 6i times 4, we have minus 24i. Minus 6i times minus 3, we have plus 18i squared. All over 4 times 4, we have 16. Then 4 times minus 3, we have minus 12i. Then we have plus 3i times 4, we have plus 12i. Then plus 3i times minus 3i, we have minus 9i squared. And now at this point now, this can cancel this to now give me, don't forget that minus 1 is equal to I squared. Therefore I'm going to have 24 minus 18 minus 18i rather minus 24i minus 18. So because this I squared means minus 1, so that minus 1 will multiply this plus 18 to give me minus 18 all over 16 Now this is minus 9I squared, which will give me plus 9, because I squared is minus 1, and that minus 1 will multiply this minus here to give me plus 9. So thank you for staying tuned to the end, and make sure you subscribe, like, and comment to my YouTube videos. Thank you.